UNIGINE offers you deferred decals, material projections on a surface, enabling you to change material parameters in certain areas on which these decals are projected. You can add various extra details at basically no performance cost. Right-click within the viewport with the Shift key pressed to open the Create menu. In the Decal submenu, you will find all available decal types. Let's create an orthographic decal, which is projected onto a surface by means of orthographic projection. It preserves the same size relative to the projection surface. You can adjust the size of your decal by setting these parameters, or you can do it via the Edit Size mode by simply dragging the sides of the size manipulator while holding the Alt key. Like all built-in node types, decals have their own base material, Decal-Based. We click Inherit to create a new one to be able to adjust it. We can specify PBR textures for the material and create, for example, an alpha mask paint splash. And we can change its color as well as other parameters. In fact, deferred decals are independent of the number of polygons in the scene, as they are rendered in screen buffers. That's why they affect only deferred objects. Decals accurately follow the shape of any surface and therefore do not cause flickering due to Z-fighting, as if a decal was represented by a mesh, just like the ones you see. You can control the intensity of shading components of the decal individually via the visibility parameters to achieve the desired result. Different results can be achieved by changing the way the normals are treated. You can see the original floor relief under the splash that looks dry at the moment, but enable the normal substitute state and the paint layer will become thicker as if it had just been poured. The state defines whether the decal normals overlap the normal map of the ground. Another decal type that uses raster textures is a projected one. It is quite similar to a projected light source, as it is drawn by means of perspective projection. Its size grows as the distance to a surface increases in accordance with the laws of perspective. You can also control projection size via the field of view parameter. Unlike the box-shaped orthographic decal, the projected one forms a projection pyramid. The radius defines the height of the decal's projection pyramid. Let's rotate these decals to see the difference, so you should choose which of these decals to use depending on the desired behavior. The third type is a mesh decal. It projects geometry and best fits for creating large, complex-shaped areas. Let's create an aerodome using mesh decals. We'll start with a decal based on this mesh of an aerodome with runways and apply an asphalt material to it. Then we clone the node just to preserve its position and specify another mesh for runway borders. We're going to use this mesh decal with the corresponding material to create transition between the asphalt and the ground. We are going to make another clone for runway surface marking and assign another mesh representing marking lines by dragging it to the mesh field. The last thing we have to do is increase its rendering order to make it drawn over the runway. Mesh decals are free from quality limitations, unlike the previous two types that depend on resolution of raster textures. A projected or an orthographic decal would require two large textures to provide acceptable quality for an area like this. Mesh decals are projected onto surface by means of orthographic projection. It provides exact matching with the surface of the landscape, which would not be possible if arbitrary static meshes were used for roads. PBR support and high-performance make decals a perfect option for creating puddles and stains, bullet holes, ashes, dust, and so on. With a decal, you can choose to modify only normals to imitate a bumped surface and control the intensity of the effect via the normal visibility option. Let's create an orthographic decal and apply an alpha mass texture of dirt. Then we adjust its size to cover the whole side of the car. The car looks not so clean now, but you can notice texture stretching on the front and back sides of the car body caused by orthographic projection. To get rid of this artifact, enable the angle fade state. Now the dirt fades away gradually. The angle fade option enables easy adjustment of coverage areas. Let's create a new orthographic decal with a default white color and adjust its size to cover the whole place. By default, the decal just paints everything in white. But once you enable the angle fade option, it will affect only surfaces facing upwards, that is, to the decal. Fine-tuning is also available via the angle threshold and power parameters. It is a quick and easy way to imitate a light snow cover without any additional geometry. We can also change the environment settings to make the scene look even more natural. Another useful option is the distance fade, which defines the degree of decal fading with distance. It depends on the radius of the decal and can be adjusted via the threshold and power parameters. Now let's get back to the sample with dirt. You can see that the wheels look unnatural as the dirt decal is projected onto them. You can filter out materials onto which the decal should be projected, so we need to prevent the wheels from being affected by the decal. For this purpose, open the parameters of the dirt decal and set up its material mask. Select a special bit for it that'll be used by all materials except the one assigned to the wheels. Then let's select a wheel and adjust the mask of its material by simply switching off that special bit. Now the wheels aren't affected by the dirt decal. Their material is filtered out by bit masking. You can manage overlapping decals via the rendering order option of their material. The way they are sorted is determined by the selected value. Increase it for the paint and it will appear over the dirt. Do the same for the dirt and everything goes the other way around. There are 17 positive and negative offsets, providing enough room for ordering adjustment. In addition to normal mapping, decals support parallax mapping too. The pit decal does not look realistic until we enable the parallax option for it. Now we need to specify the height map, and here it is, a good-looking pit on the ground. You can adjust several parameters such as height, number of layers, and noise blurring. This feature doesn't affect the source geometry but greatly improves the look of decals and can be used to imitate fractures and craters on any surface. Another application for decals is creating holes in terrain surface. A special material named Decal Terrain Hole Base must be assigned to the decal for this purpose. This can be used when you need to cut an area of terrain and substitute it with a static mesh representing a cave, bridge, complex-shaped slope, etc. The feature supports texture-based alpha masking and semi-transparency imitation by using the jitter transparency as well. This effect skips certain pixels according to a dither pattern and produces a light noise. Usage of this feature is shown in the arbitrary terrain generation video tutorial. When you create a hole in terrain surface in the area covered by vegetation, grass or trees appear to be floating over the hole. In this case, you can use the Cutout Intersection feature. Specify a special bit pattern of the intersection mask of the decal and then enable the same bits in the Cutout Intersection bit mask of grass and clutter objects, and the decal will dynamically cut out the grass it intersects with. Decals can be projected onto the global water surface. For this purpose, just enable the water decal state of the material. You can apply textures to imitate various floating objects and have a procedural foam rendered around them. By switching off normal substitution, you will make the object look more liquid or slightly submerged. You can use this to add some stains or spills on water surface. You can create a water decal via the water section of the Create menu. A large number of decals rendered in the scene may significantly affect performance. The best practice is to enable fading out for decals that are no longer needed. You can enable fading of decals by using these time parameters. If you have a geometry that is flat enough, you can use a plane primitive instead of a decal to save some performance. For alpha masked objects, the alpha test blending preset should be selected. Pump the geometry up a bit by setting the geometry inflation option to wire to avoid z-fighting of surfaces. You can also fake semi-transparency by enabling the jitter transparency option. Although this approach produces noticeable noise at closer distances, it really is useful in terms of performance optimization. Using decals, you can make your worlds look more natural with a massive amount of details. These are the most common use cases for decals. For more details, please refer to our online documentation.